Assalamu alaikum students. After finishing the topics of stress and strain, now we are aware that we are having three types of stresses and the respective three types of strains. After it, we should have the knowledge of Hooke's law. What is Hooke's law? Hooke's law simply states that stress is directly proportional to strain. That means if a body is under a lot of stress, then there is also a lot of strain within the body. It was actually Robert Hooke, that's why it's called as the Hooke's law, who gave a fundamental law of elasticity. And according to this very law, if all small deformations, the stress is directly proportional to strain. Or you can say stress equals to some constant times the strain. Or then this constant comes out to be, it will be stress over strain equals to this constant, and this constant is called as what? Modulus of elasticity. So the ratio of stress to the strain, Hooke's law, you can simply state it in this way: the ratio of stress to the strain, that's also the Hooke's law, or simply the stress is directly proportional to strain. This very Hooke's law is an empirical law, and it is found to be valid for most of the materials for different types of stresses and strain, provided that the deformation is very small. For some materials which follow this very stress strain linear relationship, because it will be a linear relation. One is the strain is more, there will be more stress. One is the stress is more, there will be more strain. The maximum stress, the maximum value of stress up to which Hooke's law is obeyed and the body completely regains its configuration, original dimensions, after removal of applied force, that's called as the elastic limit. You have to remember here a term that's called as elastic limit. What is elastic limit? Elastic limit simply means once a body is at a stress, and if that very stress is removed, if the deforming force is removed, because of the deforming force there will be stress and there will be strain, and once the deforming force will be removed, then the body tries to regain its original configuration, and till the body regains, if I am applying a force of 5 newton, if I am having this very body, this very rod, and I am pulling like this or this, there is a stress, there is a strain within this very body. If then I am increasing the force, if on increasing the force, a stage is going to reach that it is not going to regain its original configuration. Till it regains its original configuration, we can say that that thing is called as elastic limit. Elastic limit is simply the maximum value of stress up to which strain is obeyed and the body completely regains its original configuration. Elastic limit means once the body regains its original configuration, one is the stress is removed, one is the deforming force is removed, then that thing is called as simply elastic limit. Now we can also say that within elastic limit the body behaves as an elastic body within elastic limit, because once the more and more forces are applied, there will be a permanent change and body does not behave as what? As an elastic body. Now within the elastic limit, the ratio of stress to the strain is a constant, and that constant called as the modulus of elasticity. Now as we are having three types of stresses as well as three types of strains, so this very modulus of elasticity, now modulus modulus of elasticity is of three types. What are those very three types? The number one that is called as, that we are going to discuss, that is called as Young's modulus of elasticity. Young's modulus of elasticity, and it is denoted by y. We'll first discuss it here. This Young's modulus of elasticity is simply defined as Youngest modulus y is defined as normal stress or longitudinal strain. Longitudinal strain. Now let me explain. If we are having this as a rod here and it is having a length of L, on applying a force, what will happen? There will be increase in its length a bit. That we will say it will be like this. It will be, it was till this very point it was L, now it is a bit, it is delta L and it is L. So new length of the rod becomes as what? L plus delta L. The first length was L. Now the normal stress within the body will be how much? That will be, so if we will define now y is equal to normal stress. Young's modulus is defined as the ratio of normal stress to the longitudinal strain. Now how much will be the normal stress? Normal stress will be, if there was a force of F on it, it will be force over area, because it is having an area of A, over longitudinal strain. Longitudinal strain, as we know, that is equal to the change in configuration to the original configuration. So that will be how much? That will be change in length, delta over delta L over L. So we'll be having F L over A delta L. This will be the equation for what? This will be the equation for Young's modulus of elasticity. So Young's modulus of velocity, we have to remember here that the larger the value of Young's modulus of velocity, larger will be the force required to change the length of the material. If this will be very very large, then we have to apply a large force in order to make a small change, make a small increase in its length to change the length of the material. Or for a rigid body, if we are having a rigid body, that means delta for, it is very much important for rigid body. Rigid body means where there is no change in dimension. That is delta L equals to 0. Once delta L here equals to 0, this whole term becomes as A into 0, that is 0, FL by 0, that's infinite, then Y tends to infinity. So whatsoever force you are going to apply, there will not be any change in the length of the body. So you have to remember, if delta L for a rigid body, the conditions, Young's modulus tends to infinity. And you have to once again understand this very factor, that if Young's modulus, if this is larger for somebody, then F has to be very very larger. And besides, Young's modulus of an object depends upon the nature of the material. It doesn't depend upon the dimensions, the length, breadth, area. It doesn't depend upon that. And you have to remember this very, for rigid body, delta L is equal to 0. As delta L is equal to 0, that means Y tends to infinity. Tomorrow will be with another lecture. Till then, Allah Hafiz.